We move on to matrices. So a matrix is very similar to a vector, only that it has several lines and several columns. So I would like to define a matrix with 2 rows. So again, I clear all my environment and then I say capital A. So usually matrices are capital letters. And then I say first line equal to 123.5. And second line, oops, here what I do, I go to a new line. It's also a valid way to say that I'm changing line. And so it's 3, 4 minus 2.1, and then I close, and then enter, and my variable is defined as a matrix. Instead of new line, I could also have used the semicolon. If I want to write all these on a single line, so I take B equal to first line 0, 2, 4, and then second line, so now with the semicolon, 1.5, 3 minus 0.3, and I close my brackets, and I see my new matrix. So the two have the same size, and I can do a sum between them. So C equal the sum of A minus 2B. So here I do at the same time a sum between matrices and a scalar multiplication, and I get my new matrix of the same size. I can also concatenate two matrices. So now I say D is a concatenation of A with B, and since I put a comma, these are side by side. Okay, so my D is a 2 by 6 matrix. But now I cannot do the sum between these two matrices, so for example A and D, because their sizes are not compatible. Let's see now how we can work with these A, B, and D. So I take, for example, a new matrix, which is a concatenation of D, and then semicolon, and then I take twice D again. So first I will have the matrix D, and below twice D. And then the size of D is 2 by 6, and the size of the new matrix, it will be 4 by 6. So I doubled the lines, the number of lines. So I can extract, like I did for the vectors, some entries of this matrix. But now I have to give two ranges, one for the columns and one for the lines. So I take entry 2, 3, and so this is minus 2.1. I can also take the entries from 2 to 3, comma, 4 and 6, and then I get this 2 by 2 matrix, which is extracted from a matrix matrice. So if I take A that we used earlier and I transpose it with the same symbol as before, I get a 3 by 2 matrix. Okay, so the transpose is this dash. There are also special matrices. For example, a matrix which is only zeros. So I can define mat null as zeros, and then I have to give the size. Before I gave 4.1 or 1.4 for a vector, and now I can give a matrix sizes, which is, for example, 3 times 4, a 3 by 4 matrix full of zeros. And equivalently, there is a matrix which is filled by ones, and the common is ones, and I define mat uns equal to ones 3.4, and I get my 3 by 4 matrix full of ones. I can also build the identity. The identity is a diagonal matrix with ones on the diagonal and 0 elsewhere. So here I 3, 3, 3, 3 is the size, so is the identity matrix 3 by 3. In reality, what this function does is to produce a vector of the size which is indicated in the arguments, and then fills with ones in the diagonal. So it is even possible to define a diagonal matrix from a given vector. So I take V equal to 1, 2, 3, 4. So this is a vector, a line vector. And then I define a new matrix which has as diagonal these 4 entries. So with this line vector, I define a diagonal matrix equal to diag of V. So the size will be automatic, and I see this diagonal matrix with 1, 2, 3, 4 on the diagonal. I can also do the opposite operation. I have a matrix A, so recall what it is, and now I can extract the main diagonal. Here it would be 1 and 4. So I define the vector U equal to the diagonal of A. And I get the vector 1, 4 as a column vector. If I want a row vector at this point, I have to transpose the diagonal of A.